REST and gRPC solve the same broad problem. They let services exchange data, but they optimize for different environments. REST is familiar, readable, and easy to expose to browsers, mobile apps, and external consumers. gRPC is faster, more contract-driven, and usually stronger for tightly controlled service-to-service traffic. So the real question is not which one wins everywhere. The real question is which boundary in your system you are designing. REST is built around resources. A client calls paths like /users or /orders and uses standard HTTP methods such as GET, POST, PUT, or DELETE. The payload is often JSON, which makes requests and responses easy to inspect with ordinary tools. That is a big reason REST is so common for public APIs, web clients, and mobile apps. Developers already understand HTTP, so the adoption cost stays low. In practice, REST feels open, readable, and operationally familiar. gRPC starts from a different mental model. Instead of focusing on URLs and resources, you define service methods such as createUser or getInvoice. Those methods and message shapes live in a protocol buffer schema, and client or server code can be generated from that contract. The result is a strongly typed interface with explicit request and response messages. gRPC usually runs over HTTP2, which also helps with efficient transport behavior. It feels more like calling a typed internal function across the network. One major gap is text versus binary and loose versus strict contracts. REST commonly sends human-readable JSON. That is excellent for debugging and interoperability, but it is more verbose. gRPC usually sends compact protobuf messages, which are smaller and often quicker to serialize. More importantly, gRPC pushes teams toward explicit schemas and generated clients, while REST allows more flexibility and looser conventions. That flexibility helps at the edge of a system. Inside a busy microservice platform, stricter contracts can reduce ambiguity. If you are building an external API, REST is usually the safer default. Browsers, API gateways, documentation tools, and third-party consumers all understand ordinary HTTP extremely well. A developer can curl a URL, read the JSON, and understand what is happening. That matters when your consumers are outside your team. REST also fits naturally with public docs, gradual onboarding, and broad compatibility. So, for internet-facing APIs, partner integrations, or anything browser-friendly, REST usually wins because the ecosystem around it is so mature. Inside microservices, the conditions change. Your services are owned by the same organization, the consumers are known in advance, and you often care about lower latency, smaller payloads, and contract consistency across languages. That is where gRPC becomes attractive. A Go service, a Java service, and a Python service can all compile the same schema and agree on the same fields and types. Client stubs are generated rather than handwritten. This makes internal integrations more disciplined and often more efficient. Another reason teams choose gRPC is streaming. REST is usually modeled as one request and one response. You can emulate streams with other patterns, but it is not the natural default. gRPC supports unary calls, server streaming, client streaming, and bidirectional streaming in a first-class way. That is useful for live updates, telemetry pipelines, and any workload where messages keep flowing over time. The hardest trade-off is usually not raw performance. It is openness versus control. REST is forgiving. You can evolve it with looser conventions, lighter clients, and broad tooling support. That helps when many consumers move at different speeds. gRPC is stricter. That strictness can improve correctness and client safety, but it also means more schema governance and more dependence on generation workflows. So the choice is often flexible edge communication versus tightly governed internal communication. Many mature systems use both. They expose REST at the edge so browsers, mobile apps, and partners can integrate easily. Behind that edge, a gateway or backend for front-end may translate those requests into gRPC for internal service calls. That gives you public simplicity and internal efficiency at the same time. The decision is architectural, not ideological. Here is the short decision guide. If your API is public, browser-facing, or partner-facing, start with REST. If the traffic is internal, high volume, multi-language, and tightly controlled, gRPC is often the better fit. If your platform has both kinds of boundaries, use both deliberately, REST at the edge and gRPC between internal services.